Hi everyone, I'm Jim Bennett. I'm a Senior Regional Cloud Advocate at Microsoft, and I'm here to guide you through getting started with GitHub and making your first code commits. So this session is all about contributing to your own repositories. In the next session, you will start collaborating in teams to work on a kind of a group project. So the idea here is just to kind of lay those foundations of GitHub, making code changes, to kind of get you ready for everything else that's happening through this event. So how does GitHub work? So GitHub is a collaboration platform that uses Git for version control. And it's a popular place to share and contribute to open source software. Now, we touched a little bit on the last session on what GitHub actually is, but let's just watch this quick video just to kind of give an introduction to GitHub.
Okay, what is GitHub? Well, GitHub is a platform that helps people solve problems by building software together. So, how does it work? This is Sam. Sam works on tractors all day, but not in the way you might be thinking. She builds the software that helps make tractors more efficient. And she does this on GitHub with the help of her team, VJ, Melinda, and Mike. Now, even though they all work on the same project, Sam and her team don't all work in the same part of the world. This is Eddie. Eddie also works on tractors all day, except he actually works on the tractors all day. And this is the Harvester L700. It's the latest flagship in the company's fleet of tractors. It's full of sensors and processors that produce a ton of diagnostic data. Eddie has a great idea for how farmers might share their data and improve their harvests. So Eddie opens an issue on GitHub. Issues are discussion threads where people can report bugs, request features, or even just ask questions. Sam is the first one on her team to see Eddie's issue, and she thinks that VJ would be the best person to start the job. And here's where we get into the nuts and bolts. Eddie isn't the only person using the Harvester L700. All over the world, other tractors are collecting moisture data, and they need to keep running smoothly even while VJ is working on the new features. He needs a dedicated place to experiment so none of his changes end up on the farm before they're ready. So he creates a branch of the code, an alternate timeline where he can safely make changes to the software. Now he's ready to start writing the new feature. GitHub tracks VJ's changes and saves snapshots of his progress. When he's ready to collaborate on the changes with his team, he opens a pull request on GitHub. Pull requests let you show others the changes you're proposing so they can review and discuss them. This means VJ's teammates can help with roadblocks and even make improvements. On GitHub, everyone has a copy of the project. So if Melinda has an idea for something that will help make VJ's work even better, she can add it to the branch herself. GitHub keeps a record of everyone's contributions and feedback in the pull request, alongside relevant messages from the team's other systems. Once the team has signed off on the changes, VJ can incorporate the new code into the project. The new feature will be available to everyone as soon as he merges it in. Now farmers everywhere can all benefit from Eddie's great idea. But this is really only the beginning of the story. Because GitHub is the largest community of developers in the world, with millions of people sharing their projects, Eddie's idea could end up helping people in unimaginable ways. What kinds of problems are you trying to solve? Whether you're an engineer, a code enthusiast, or even a farmer trying to harvest grain, software touches every corner of our lives. GitHub is where people build that software. It's how they build software. Together.
So now we've kind of seen what GitHub actually is, let's actually work on creating a repository and making code changes. So the first step we're going to do is create a repository. And this repository is going to contain information about you that you can share on GitHub. So we're going to create a special repository that can be used to add a description of yourself to your GitHub profile. So what is a repository? So we're going to create one. What exactly is a repository? So a repository, or repo as it's popularly known, is a project that contains files and folders. And this repository tracks the versions of these files and folders. And these files and folders can contain project code, images, and other assets. And these track the versions. So whenever you make a code change or someone else makes a code change, this is tracked against who made that change. Now on GitHub, a repository also has additional features, such as tools for tracking issues, which are items to be done, such as code features or bug reports, and actions, which is code that's run at times, like when your code is checked in. So these actions can do things like run tests or deploy a new version of your project. There's a lot of other features as well. You can include things like discussions to talk about your project. You can include project tracking. There's a whole lot of other things that are included in GitHub around a repository. These features are not native to Git, the underlying version control system. Instead, they are project tracking features that come from GitHub. So let's just start with this quick video to go through what a repository is and kind of explore a repository.
The GitHub repository is the container that holds everything related to your project. The code view is where you will find the files included in the repository. These files may contain the project code, documentation, and other important files. We also call this view the root of the project. Any changes to these files will be tracked via Git version control. The README is a special file that we recommend all repositories contain. GitHub looks for this file and helpfully displays it below the repository. The README should explain the project and point readers to helpful information within the project. Issues are used to track bugs and feature requests. Issues can be assigned to specific team members and are designed to encourage discussion and collaboration. A pull request represents a change, such as adding, modifying, or deleting files, which the author would like to make to the repository. Pull requests are used to resolve issues.
Now this is an older video, so the UI has changed a little bit since the video came out, and there's been a few other changes as well. You notice this refers to a branch, touch on branches in a minute, a branch called master. Now the default branch is called main, trying to be more inclusive with the language of GitHub. It's a little bit of an old video, but this did cover what a repository actually is. Now the repository we're going to create is a GitHub profile. And this is an example of my GitHub profile. So when you go to github.com/JimBobBennett, which is my GitHub account, you will see this profile there. And this overview about me comes from a repository called Jim Bob Bennett. So whenever you have this set up, what you do is you create a repository that's got the same name as your GitHub user. And then the contents of this is loaded from a file called readme.md. Now, MD files are markdown files. And this is a way of writing text with styles, but using characters in the text to define what style to use, or to add images, links, and more. We'll look at Markdown a little bit later on in this session. Now, README files are also a little bit special. So whenever you view a repository or a folder in a repository, if there's a file called readme.md in that repo or that file, this will be shown. So see the list of files in the folder or the repository, and below that you will see the README. The README is the standard place to put details about the project, links, further documentation, and things like that. So README files are kind of a bit special. And the README file in your profile repo, so in the repo that has the same name as your user account, that is what's shown on your profile page. And that's what we're going to do today, is kind of create this profile, just so you can kind of promote yourself. It's a way of, if you're looking for jobs, you kind of show what skills you've got, and it's kind of a way to help when connecting with people. So let's actually now create the repository. A number of ways you can do this, but one of the easiest ways is to go to github.com/new, and this will give you the option to create a new repository. You will, there's also other options. If you go to your list of repositories, you'll see a new repository button. There's a plus menu at the top of the screen. You can click to choose a new repository, but github.com/new is kind of a quick shortcut to create a new repository. Now, this is the top of the form. There's multiple sections that you have to fill in. You may see an option to use a template. If you've got multiple GitHub repositories, you may see an option to use a template. If you do, leave it as no template. Talk about templates just a little bit later on, but the idea of a template is you can kind of create a pre-created repository with details already filled in, maybe a code already provided anyway, like a kind of a starter project with a web development tool, for example. You may not see this with your first repository. If you do see it, just do no template for now. Then you want to set your repository name and the owner. Now, if you have multiple GitHub organizations, if you get access through work or through school, you might have to choose the owner. You want to choose the owner as you, whatever is your GitHub username. And then your repository name should be the same as your username. So if my GitHub account is Jim Bob Bennett, my repository would be called Jim Bob Bennett. When you actually choose to set the repository name to match your GitHub username, you will see this note saying it is a special repository that can use to add a README to your GitHub profile. You can then add a description. This is completely optional, but maybe put something like profile README, something like that in the description. Don't have to add one if you don't want to. Below this, you then set the visibility. Now, a public repository is visible to everyone. So absolutely anyone on the internet can see your public repository. A private repository is one that only you have access to or people you add as collaborators. So you'll see this a lot with corporate accounts. An organization will have GitHub accounts and their open source projects will be public, but their private code is in a private repository. And only people who have access to that can see the code. Now, when you will set this up, you want this to be public. You want people to see your profile. If it's private, they won't be able to see it. So you want to make sure this is public. Now, although it's public, no one else can make changes unless you give them access. Everyone can see it, but they cannot make changes unless you explicitly give them permission. It's not public write access, it's just public read access. Then you can choose to initialize your repository, and this creates multiple files in the repository for you. So the first thing is a README. This is the default file that you want to have to allow people to see the contents of, to see information about your repository. And for your profile one, this is what appears on your GitHub profile. So you want to tick the box to add that README. This is where we're going to create your profile. The next file down is the gitignore file. So this gitignore file is used to tell Git to ignore certain files or folders when it looks at the changes you've made. So the example of this is if you have some code locally, you make a change to that code, you want Git to then see those changes, and you want to better commit those changes back to your repository. We'll look at commits in a second. But if you have like build outputs, intermediate files that get generated all the time, you don't want to add those to GitHub. If you've got builds of web apps or compiled source code object files, you don't want to add those to GitHub. If you've got files with secrets, you don't want to add those to GitHub. And the gitignore just defines the file names to ignore. For example, if you're doing web dev with npm or node, you'll have a node modules folder. You don't want to add those node modules into GitHub. So you'd add that node modules to your gitignore file. And GitHub has a whole lot of templates for web dev or Python or .NET or C++, kind of whatever programming language that you are using. Now, we don't need to worry about a gitignore file. We're just going to have our README file, but it's a good thing to be aware of. And then finally, choose a license. We have a session in the next part of this event where we look at licensing, but for now, just leave this to none, which means although people can see your code, you not grant them any rights to do anything with your code. But let's say licensing will be covered in the next day of this event. So once you set all this, select create repository to actually create the repository. This will go off, see a little spinner, and the repository will be created. This is what you'll see when the repository is created. It will take you to that repository. The URL will be github.com/username/username. So repositories are always github.com/username/name of the repository. So the repository there, it'll have the initial file, the readme.md, and it's kind of pre-filled with default content saying, hi there, with a wavy. And you also see the note there saying this is the special repository that appears on your public profile. It's kind of reminding you so that you don't put anything untoward in this README file and have that appear on your public profile. And if you now go and look at your public profile, so if you go back to github.com/username, you will see it's there. You will see the contents of your README is there with your hi there. That will be there on your profile. This is great if you want to share your profile with people, you want to talk about the activities you do, the topics you're interested in, all that goes on here. So someone can just go to github.com/your-username and they can find all the details about you. You can put links to social media, links to blog posts, kind of videos, whatever you want on that README, and people can use that as your social profile. Well, the next step, we actually start making some changes to our README, actually updating it so it's not just saying hi there. And we're going to do this in a branch. So in this step, we are going to create a new branch. Now, a branch is a parallel version of your repository. So when you created your repository, you had a branch. Repositories have to have at least one branch. And the one that's created for you is called main. And that's kind of the definitive branch. There are many ways you can work with Git and GitHub, but a lot of people, main is the definitive branch. Main is where you release your code. Now you can create additional branches off of main in your repository and then use these branches to have different versions of the project at any one time. When you have the additional branches, you can make edits to your code without impacting main. So whatever you do on your branch is completely separate and will not make any changes to main. Main is safe while you work on your branch. And you can have multiple branches. If you had 5 people working on a project, you could have multiple branches, 1 branch each, where you work on the code. And eventually you bring these code changes back into main from your branch. And we'll look at that later on in this session. Now, just a note, in the past, the default branch was called master. This naming has been changed to be a lot more inclusive, is now called main. But you still may see references to master. You may see master being used in old repositories, and some Git tools still create master as the default branch. But main is the term that GitHub uses and has been using for a while. So let's just watch this quick video all about branches, kind of talk through it a bit more.
Every day you'll be editing files on your project or adding new files. You don't want to take risks with the code on your master branch, so you need to create a new branch. When you create a branch, you're essentially creating an identical copy of the project at that point in time that is completely separate from the master branch. This keeps the code on your master branch safe while you experiment and fix issues. Let's learn how you can create a new branch. Earlier, you opened an issue to create an introduction file. Let's create a branch that you'll use to add that file. You can create a branch by clicking on the branch dropdown and entering a branch name in the text field. When you press return, you're automatically switched to the new branch. Now, any changes you make to the files in the repository will be applied to this branch. However, a word of caution. When you leave the repository and come back, notice that GitHub automatically assumes you want to see the items on the master branch. If you want to continue working on your branch, you'll need to reselect it using the branch dropdown.
So, hands-on time now. Let's actually create a new branch. So from your repository, you will see a branch selected. It's only be set to main. If you select this, it'll drop down and give you a chance to choose the different branches, or you can create a new branch. So just type in the name, my-first-branch, into the branch selector. Because the branch doesn't exist, you'll see an option there to create your branch. Select that option and that will actually create the branch. And once it's selected, you actually see that that branch has been selected in the UI, and you will see the code of that branch. And you see this note to say the branch is up to date with main. So main is your default branch, and whenever you see notes in a branch, it tells you what is going on in the branch relevant to main. So it's up to date. My first branch has exactly the same code as main. Now, when things change, if code changes on main, you will see this change to say this branch is behind main. Code changes in the branch, it'll say this branch is ahead of main. So it gives you that information about what's happening. So it lets you know how you are compared to main. Now, whenever you go to this page in GitHub, you will see the default branch. So if you leave this page and then navigate back to it, it'll go back to main. So just make sure if you do change away from this page, you come back to this page, you make sure you select the My First Branch in the branch selector. Now what we've got here is kind of a standard Git style diagram showing different branches. At the moment, all we have on main is a first commit. That is the code commit that was created by GitHub. So when GitHub created a repository, it added some code and did a thing called a commit. We'll cover commits a bit more in a few minutes. But you've got main, you've got My First Branch. There's kind of no difference between the two at the moment. So now we have our branch, we can actually start editing the README on the branch. Now, in terms of editing files, editing can happen in GitHub or can happen locally on your computer. So you can connect the repository and download the entire repository, including a complete history. So not just here is the code, but entire Git's repository with a complete history to your computer that you can edit. And that way you can edit the files locally, or you can edit the files directly on GitHub. Now, we'll cover cloning a bit more later on in this event, but when you do clone a repository, it's not just a snapshot of the code, you literally have an entire copy of what is on GitHub. Git is a distributed version control system, the idea that everyone has a copy of everything. So when you take a copy, you can take a copy of all the branches, you can take a copy, you better navigate between the different branches, you better look at the code history, everything that GitHub knows about your repository in terms of the code, you will get if you clone it locally. Now, we're not going to clone locally, we're just going to edit in GitHub for now, just to kind of keep things a little bit easier. But later on this bootcamp, we'll be cloning the entire repository and working on your computer. So let's now edit the README file. So if when you look at your repo, you will see the list of files, which has just got the one, readme.md, and then below that you see the README. This is what I was saying, it's kind of a special file in your repository that the contents is shown when you look at your code in GitHub. And in the top corner of the readme.md file, the actual outline of the file, is a little pencil. If you click that, it'll open the file in edit mode. So it's not against the code in the list, the README file in the list of codes. It's actually in the README file, the one that's got the hi there that outputs the README file. Up in the top corner there is a pencil. Click that to edit the file in GitHub. Now, when you click the file, click the pencil, it takes you into the editor mode. And you'll see you've got two tabs inside the editor, edit file and preview. You've got the contents of the file, the note about it being a special repository, and you can see all the contents there. And this file is in Markdown format. So Markdown is a special way of writing text with characters to tell how to style the text. So let's go through this line by line and kind of talk through some of the Markdown features that we see. So the first line starts with 3 hashes. Hashes are how you indicate headings. If you've ever used tools like Microsoft Word to write a document, you can choose heading 1, heading 2, heading 3, kind of top level and subheadings. If you've done the HTML coding, you have H1, H2, H3. This is the same thing. 1 hash is the same as an H1 in HTML, top level heading, 2 hashes for an H2, 3 hashes for an H3. By default, they picked 3 hashes just to make it not look too big. But this line is saying there's a heading 3. So you don't see those hashes, you just see the hi there as a heading. So it's kind of bolder, bigger font. The next section down is marked with HTML comments. So this syntax of the less than sign, exclamation mark, dash, dash to open, and then dash, dash, greater than sign to close, that is how you do HTML comments. So when you're doing a web page, if you want to have something in your web page that is not code, that's not run, it's not rendered, it's just there for information, you use these round comments. Now, Markdown supports HTML. So you can do things in HTML in Markdown, it'll be rendered as if it was HTML. You can't do everything. You can't do things like frames, you can't run scripts, but in terms of just things you draw on screen, you can use HTML inside your Markdown if you need to. Now, this being commented out, because it's commented out, it's not shown. So if you think when we looked at this, we just saw hi there, we didn't see the rest of the contents because this is commented out. So the first line inside the comments, line 4, we have 2 stars before and after username/username. And you actually see it's rendered in bold. When you surround text with 2 stars each side, that says do this text in bold. Then the word special, it's underscores either side. When you have underscores either side of text, that means italic. Now there's no spaces between the underscores and special or the stars and username. If you do put spaces, it doesn't actually format it. So if you want to actually have an underscore, you just wouldn't have underscores either side. You just have underscore space, and you can actually have the underscore there. The word readme.md is inside backticks. This puts in a monospace font designed to look like code. So this is one way you can render code on screen, is by putting it in backticks. Then we've got a whole of lines that start with a hyphen, and these are bullet points. You can do it with hyphens, you can also do it with a single asterisk character as well. Hyphen space or asterisk space, that gives you bullet points. And you can do more with bullet points. If you want to indent them, you just have one bullet point with a the hyphen at the start of the line. Next line down, you indent it by 2 spaces, and that becomes a sub bullet. Things like that. It's kind of got a bit of power around creating bullet points, but there's a whole lot of bullet points here. Now, whenever you change this code in the Markdown file, you can see the changes in the Preview tab. So you click on the Preview tab now, you'll just see the hi there. Everything else is commented out. But if you were to make changes to the file, you could then go and look in the preview to see what it looks like. So let's actually make some changes. Let's actually make some changes to README file now and see what it looks like. So as some example changes, if I were to make the hello there an H1, change from hi there to hello there, put a single, and just make it an H1, a top level header, I can put a single hash there, and that then makes it a top level header, so it makes it slightly bigger. And then I'm going to put 3 bullet points in there. So I'm working on open source, learning about GitHub and open source, and looking to collaborate on open source. 3 bullet points in there using bonuses. If I do that in the text, and then look at the preview, you can see we've got the bold, larger heading, and then the 3 bullet points. So take some time, think about what you want to put in your README, and update your Markdown. But now we've made our changes, it's time to commit these. And a commit is a set of changes to the files and folders in your project. And a commit exists on a branch. So a commit is a group of changes. So a commit contains just the differences between the file before you changed it and the file after you changed it. So if you added a line, it just contains the line that you added. And you get a group of file changes in one commit. So you submit your commit as a single entity. It can be one file, it can be many files, kind of whatever works for you. And these commits are fixed, defined changes done by a person. So somebody can then look at the history of your repository or history of a branch and actually see that person A committed these file changes, person B committed these file changes, and the dates when they happened, things like that. So each commit is listed against the person who did the commit, and against the commit as well, you have a message that describes the change. So you make some changes, you would commit that with a description of your changes, and that goes against you, and that appears forever in the history of the Git repository. Now, below the edit box, where you were editing the README file, below that is a set of controls to commit the file. First section is the commit message. Now, GitHub helpfully has a default update readme.md, but you can put something different here if you like. You can put first draft of my profile with details, kind of whatever you want, but this is where you can actually put a brief description. Now, this is designed to be short. It's limited to something like 72 characters. So just this way, you want just a quick comment. And a lot of times if people are working with issue tracking systems like GitHub or Jira or other platforms, they might put something like the issue number that they're working on or other kind of information. It's kind of good to have some useful information in the commit. And you can also add a description. This is optional. You can add an extended description. There's a reason for putting more information in there. And then when you're done, you can choose whether you want to commit directly on the branch you're working on or create a new branch. Sometimes you might want to make your changes to a new branch and and look at those pull requests, which we'll look at in a minute. But really, we would just want to commit this directly to the My First Branch branch. We've created a branch with these changes. We want to do that there. So add the message if you want to, add a description if you want, and then select commit changes to actually make that commit. And then this Git graph shows what we've got. So on our main branch, we have the first commit that GitHub made for us. So this was going from no files in the repository to the readme.md file. That was made by GitHub. That is on main. When we created our branch, we branched from that first commit. So every time you create a branch, you say, I want to branch from a particular commit. You create that branch from that commit. So we've taken a branch from the first commit, and then we've committed the profile readme changes to the My First Branch branch. These changes are not on main. If you go back to main, you will not see these changes. These changes are just on My First Branch. Now, because we took the My First Branch from the first commit, if we were to commit something to main, that would not be on the My First Branch. My First Branch is taken from a point in time, which is that first commit. And that's true in every branch you take. When you take a branch, you take it from a point in time. So you branch based off a commit on the source branch. Yeah, that source branch can keep moving forward, but your branch won't change unless you explicitly want it to. So we've got our branch, we've got our space of our first commit of main, and we have our one change on that branch. Just on my first branch, not on main. You can flip back to main and you'll see there's changes up there. Now, these commits only contain the changes. This is a very important point. It does not contain the complete file. So actually the commit that's sitting on the my first branch doesn't have the entire readme.md, just the changes. Now, you may have changed the entire file, in which case those changes will contain the entire file, yes, but it just has lines added, lines removed, text changed, just those changes, not the entire file. This is kind of fundamentally important to how Git works, is it just tracks the changes. So the next step, now we've got a commit, is to actually share this change to a thing called a pull request. So collaboration through Git and GitHub happens on what's called pull requests. And a pull request is a request to pull your changes from one branch to another. So in this particular case, want to raise a pull request to pull our commit with the update through README file from our my first branch into main. Now, this might seem strange, it's just you working on your code. Why don't you just change the code? Why raise a pull request? But pull requests are an important way for multiple people to collaborate on code. A pull request is an invitation to collaborators to review your code before it is accepted and ask for any changes that are needed. So if you're working in enterprise, you're working on enterprise software, you're working for a company, kind of whatever, when you make a change, you don't just push the change into production. That change needs to be reviewed. And a pull request is a way to ask people to review your code. Now, the language does seem a bit weird. It's a pull request, whereas if I raise a pull request, I'm asking you to pull my code. Kind of think maybe should it be a push request? I'm requesting to push my code to you, but the language is very much from the point of view of the target branch. So we are requesting the target branch, our main branch, pulls code from our my first branch. Now, pull request is often abbreviated to a PR. So you hear people talking about, I'm going to raise a PR, I raised a PR, have you reviewed my PR? So PR is the standard term for a pull request, standard abbreviation that a lot of people use. So let's just watch this short video all about pull requests, kind of go through this in a bit more detail.
Pull requests are used to propose changes to the project files. A pull request introduces an action that addresses an issue. It's considered a work in progress until it's merged into the project. Now that you've created a file, you'll open a pull request to discuss the file with your teammates. You'll notice GitHub knows that you have added changes to your branch and helpfully recommends that you start a pull request. Go ahead and click the big green button to start your pull request. Notice that we can use the dropdown here to compare any two branches. We'll leave the default selected. GitHub pre-populates the pull request title with your commit message, but you can update this to help your collaborators better understand the intent of your change. Below, you can leave a comment to describe the changes you made and why. As a best practice, you should reference the original issue or issues using the number sign notation. When you're finished, choose the option to create a pull request. Similar to the discussion thread on an issue, a pull request creates a discussion about the changes being made to the repository. This discussion is found in the Conversations tab. The Commits view contains information about who's made changes to the files. Each commit represents an updated view of the repository, which allows us to see how changes have happened from commit to commit. The file's changed view allows you to see the change that is being proposed. We often call this the diff. Notice that some of the text is highlighted in red. This is what's been removed. The green text is what's been added. If you notice something needs to be changed, you can click on the line number in this view to create a line comment. Line level comments are a great way to give additional context on recommended changes. Notice that the line comment was added to the main conversation. If your comment is more general in nature, you can also add a comment to the pull request using the same method we learned for issues. Most project teams require someone to sign off on the change before it's merged. We like to use emoji to show our approval.
So now actually let's raise this pull request, and let's raise this pull request to copy our changes to main. Now you'll see a note at the top of this picture here saying my first branch had recent pushes less than a minute ago. When you make changes, you push those changes to your branch, but when you want those changes to move to the main branch, you are asking the main branch to pull the changes. It's kind of a bit of language about push and pull. When you make changes, you push them, but when you want people to take your changes, they pull those changes. It's kind of good to have that distinction. So once you've made the change, you'll see in your repo, you'll see that my first branch had recent pushes less than a minute ago. This is going to help me telling you that you've made changes. And it's giving you this option to compare and pull request. You also see that this branch is one commit ahead of main. Originally, it said it was up to date with main, which meant the branch had exactly the same set of commits on it that main has. But this is now saying you're one commit ahead. So you have some changes on your branch that you might want to put into main. So you now select that compare and pull request button. That will allow you to create the pull request. So once you do it, you'll get this open a pull request form, and you can choose the source. You can choose the whole setup for this pull request. So we're going to go through this piece by piece because there's kind of a lot on here. So the first thing we do when you raise a PR is you specify which branch is receiving the changes, it's the target branch, and which branch the change is coming from, the source branch. So you're saying my target is pulling changes from my source. Now, what you want to do is make sure that your target branch is main and your source branch is my first branch. So base is the target branch, base should be main, and then compare my first branch. You're saying I want to take my changes from my first branch to main. There's kind of a helpful arrow on the screen showing you the direction. So my first branch to main. There's multiple choices here. You can drop this down if you have multiple branches. You can merge in all different directions if there's changes. But here, it's my first branch going to main. Now, when you actually apply the pull request, it just applies the changes that were made. It doesn't copy the entire file, won't replace the entire README file. It'll just add the changes. Now, what this means is if you have changes on main to the same file, you may or may not hit a problem. If the changes you made in your branch do not impact the changes that have happened since you took your branch, it'll work fine. If you branched off from one point in main, you added something to the bottom of a file, somebody else added something to the top of the file, Git's smart enough to kind of bring those two changes together and make it work. However, if somebody's made changes on main and you have made changes to the same section of the file on your branch, Git may not know how to bring those files together. You get what's called a merge conflict. We'll actually look at that later on today in one of the upcoming sessions. We'll talk about merge conflicts. And Git will helpfully tell you whether you're able to merge or not. Right now, you should be able to merge because only you have changed the file. But we will see situations later where other people have changed the file and we'll show you how to resolve these conflicting changes called merge conflicts. That comes later on in this event. So the next section is where you describe the pull request. Same as you did with the commit. You've got a title, a message, and a description. Now, imagine you're making a big change. You're making a small change for yourself. You know what the change is, you did it. But imagine you're making a larger change. You're collaborating with a big team working on some software, whether it's in the world of work or open source. If you're making a big change, you need to describe the change. You need to describe why you've done it, what you've done, what you've tested, a whole lot of stuff. So this description is where you can kind of put this information. You can talk about the reason for the change, the implementation, testing, ask questions. Hey, I made this change. Is the right thing? This is the start of your collaboration process. So the whole point of a pull request is it is a collaborative process that takes your changes, brings others in to review these, and then allows you to update your code based off feedback, and then finally have your code committed. Sometimes you might make a trivial pull request, fix a spelling mistake, whatever, it's fine. Yes, done, looks good to me, merge it in. But other times, if you're making large changes, they could end up with a whole big discussion after the pull request. It could be, can you make this change? Have you thought about that? This is a great place for people to discuss these pull requests. And this is great for people working in asynchronous manner. And by that, I mean, if you're not in the same room and you can't literally wheel your chair over to somebody else and talk to them, you will need to have this ability to have this discussion. But even if you can, even if you're in the same room, having these discussions in pull requests are great because it documents the process. If you make a change, you explain why you made the change, then someone asks for updates, and then you make those updates, that becomes documented. It's kind of a big problem in technology of what's known as tribal knowledge. Somebody knows why something was done, that person leaves, that means nobody knows why it's done. You actually document this thought process in a pull request. It's kind of a great way for documenting the why of the code changes. This description field is Markdown, so you can add styling, images, links, all that kind of stuff using the full features of Markdown. Final section, not going to touch on this today, but final section where you can actually ask for reviewers, assign work, or label the pull request. So the whole point of pull request is collaboration. So if you're going to submit some code, you don't want to create a pull request and then just hope someone's going to pick it up. You want someone to actually pick up the work. So for example, you could say, through my reviewers, I'm going to ask Rod, Jane, and Freddie to be my reviewers. And then say Jane might pick it up, signs it to themselves because they're working on it. And then, oh, Jane's got a question for Freddie. So Jane can ask that question in the pull request, reassign it to Freddie, who can then look at the thing and sign it back if changes are needed. So they've got this nice flow of you can say who's responsible right now. I would like these people to review it. This person is reviewing it, so it's assigned to them. They need changes, it's assigned back to me. Something like that. Great if you're going to track in your work. You can also attach labels as well. So you can label by the product area, bug fixes versus enhancements, a PR that adds tests, a PR that adds documentation, kind of whatever system makes sense to you. There's no hard and fast rules around labels. These are for you to agree in your team, or if you're contributing to open source, for the open source project to decide on when it comes to labeling pull requests. So once you're ready, add a description, something like update my profile README to share more about me, then click create pull request to actually create the pull request. Once you've done that, you'll better see in the pull request tab your pull request. You'll see there's a count of 1. That shows there is a pull request there, and you'll see that pull request. So next step, you create the pull request. Now let's talk about merging the pull request. And a merge is the act of applying your pull request to pull the changes into the target branch. It's not copying the files that were changed, not just copying the files, it's taking the changes and applying those changes into the target branch, in this case the main branch. There's kind of a whole flow you can use, that different people can use to actually how you would create a pull request, make changes, and merge that back in. There's a number of different flows you can use, and this short video goes through what's called the GitHub flow. It's kind of a suggested way of using GitHub.
The GitHub Flow is a lightweight workflow that allows you to experiment with new ideas safely, without fear of compromising a project. Branching is a key concept you'll need to understand. Everything in GitHub lives on a branch. By convention, the blessed or canonical version of your project lives on a branch called master. When you're ready to experiment with a new feature or fix an issue, you create a new branch on the project. Now, the branch will look exactly like master at first, but any changes you make will only be reflected in your branch. Such a new branch is often called a feature branch, and you should give yours a descriptive name. When you make changes to the files within the project, you'll commit your changes to the feature branch. When you're ready to start a discussion about your changes, you'll open a pull request. Now, a pull request doesn't need to be a perfect work of art. It's meant to be a starting point that will be further refined and polished through the efforts of the project team. When the changes in the pull request are approved, the feature branch is merged onto the master branch.
Okay, so let's actually merge the pull request. This is the pull request form, and this is where we can merge the pull request. So let's actually go through this form in a bit of detail, because there's quite a lot here. So the first thing is the conversation tab. This is where conversations happen around the issue. So GitHub is great for remote and asynchronous teams, as reviews can happen at any time. In fact, GitHub was built with remote teams. So for example, a developer in France can raise a pull request in their morning, and then assign it to a developer in Brazil, who might look at it and make comments in their afternoon, which is after the French developer has gone home. Next morning, a French developer comes in, sees their comments, and then addresses those comments, ready for when the Brazilian developer gets into work. It's kind of got this lovely asynchronous flow if you can just document all your thoughts. Now you can do this through comments, just you keep adding more comments with Markdown and keep commenting and discussing in the pull request. Now you can make changes. If you make any changes to your code and you commit them to your branch, they are automatically included in the pull request. So somebody asks for changes, you make that change, you commit it to your branch, it automatically picks up the pull request. This pull request is about merging a branch, not about merging a specific set of changes in the branch. So it's always based off the latest version of the branch. So if you push something to the branch, that immediately gets added to the pull request. And then as you add changes, they appear in the conversation. You can also add things like checks. Can the code be merged without any merge conflicts? That's a standard check that is there. You have to make sure the code can be merged before you can do it. But you also add extra features. You can say you have to run unit tests before the code can be merged. The unit tests have to pass. You have to sign a contributor license agreement. We'll be talking about these later in this event. But you can put a whole kind of process in place to just block people merging code. Then from here, you can just merge the pull request if you want to, or you can just close it. Say, no, we're not going to merge it, we're just going to close it. We're just going to leave it as it is, kind of get rid of it. Now the next tab is the commits tab. And this shows all the commits in the pull request. And that way you can kind of look at the different commits if you want to kind of see the kind of the steps that have happened, the changes that were made. Yeah, you look at the pull request, I want some changes, one more commit comes in, you can look at that one commit to see whether that matches the changes that were requested. Next is the Files Change tab. And this shows all the files that were changed in this pull request. It shows the lines that changed with red for text removed and green for text added. So here we've got a whole of text removed that's red, and green is the new text that was added. You can make comments inline in this view if you want to. So you hover over it, click a plus button, and make comments inline. So rather than just having a conversation of, hey, you need to change this thing, you can actually apply that conversation to the lines in the code. And once you make that, once you actually add a comment to a line, that appears in the conversation tab. So let's merge this PR. We've talked about it, let's actually merge this. It's usually good to do some kind of comment to say that this pull request is good, you're happy with the changes, thumb up emoji is a popular one for this, or LGTM looks good to me, approved, what have you. It's usually good to have some kind of comment, and then select comment to make the comment. Yes, this is good. And then finally, you can then select merge pull request, and that will merge the pull request. Now, once you've selected merge pull request, it'll ask you to put information in. The reason you put information is this creates what's called a merge commit. So this will create another commit on the main branch to say I'm merging things. So you end up with the change you made and the merge commit. And so you need to give that message and a description. So by default, it says merge this, update README, and just click confirm merge. So there's nothing you can, no need to worry about adding extra detail. You can if you want, but otherwise just select confirm merge. So this is kind of the Git graph of where we are. We had our commit. We made that change to the profile README, which is on the my first branch, and then we merged that change back to main. So the changes were made on my first branch, and those changes have been merged back to main. We'll actually see a note in the pull request saying it's successfully merged and closed, and an option to delete the branch. So the conversation is updated to show it's been merged, and this shows the option to delete the branch. Now, if you're finished with the branch, it's good practice to delete it. If the branch is not being used, then you don't need it clustering up the branch list. Once you delete it, you can get it back. It can be restored if you need to, but really, a lot of time there's no need. I finished my work has been merged, let's delete the branch and get rid of the noise. So this Git graph shows where we are now. We only have the main branch. We've deleted the my first branch. And on our main branch, we have our first commit, created by GitHub, to create the README. We have the actual commit that was made on my first branch that's now been merged to main with the profile README. And then we have the merged commit, the commit that says, yes, we merged code from another branch. So that ends up with 3 commits in the branch. If that's done, the my first branch has been deleted, this is what main looks like. You're done. You've successfully created your profile README. Now, there's a lot we can do with Markdown. So after this event, there is a communicate using Markdown lesson on GitHub Skills at skills.github.com. So if you want to go and check that out, you can learn more about things to do with your README, how to add images, links, and kind of do more cool things. Now remember, these READMEs are public. So if you find one that looks really cool, you can just look at the Markdown and copy it. So another good top tip is to build your README, is to find a README that you like, and just, it's open source, so think about what you can borrow, what ideas you can take.